All right, welcome. Today's presenter is Jason Lowe from NC State's Industry Expansion Solutions. Jason, it's all yours.
Thank you very much, Susan. So good morning, everybody. It is a wonderful end of winter day here in Raleigh, North Carolina. So it is very much like spring today. So welcome to a webinar that I prepared. And it's actually become my thought process is that we're going to have a series of these over time that address some of the common questions that I get when I go out and do assessments and meet with small manufacturers. So this particular session is actually a second installment of what I had last fall called Smart Manufacturing Journey Starts Here, where I started talking about some smart sensors and how they can be used in our small manufacturing environments and implemented with low cost and low effort. So I wanted to do a little bit of a recap of our last webinar, talk about protocols. This might be the more painful thing of my talk today is talking about some of the protocols and the specifications, things that we may not be that up on or interested in, but it's important to discuss. We'll talk about two more protocols today that are becoming widely accepted in industry and manufacturing in the communication controls world, and what a system might look like, an integrated system might look like, what we can expect to get out of those systems. And I'm going to conclude with an example that I built that I think drives home the point. And then I invite you again to come to another installment, and I'll talk about that more at the very end. So let's kind of set a baseline here. Why are we here? We have an interest in automating, and we're curious about why you have a decision to automate. What are your motivations to do that? And that's a lot of what I do in IES, is to go out to small manufacturers and understand those needs. We always want to make sure that everything is well defined and documented. And we talk a lot about continuous improvement efforts, and that's a lot of the work that we do here in IES, as many of you know. And then we define what requirements that you'll need, how we can help you. And one thing that constantly is presented is who can do this work. So as you may know how our services work, we provide a lot of the technology basis, the information, and the connections, but sometimes there's not a great deal of internal technical knowledge that you might have and need to do a lot of these things, and that's some of the motivation for these series that I'm hosting, is to get you comfortable with some of the talent that you might need to implement some of these solutions. So that's always part of the conversation that I have when I go out and meet engineers and technicians and management folks at small manufacturing companies. Who are you targeting to help you with some of these solutions? And if there aren't internal solutions, then we can investigate who might be beyond the walls to help you, and hopefully that's local. So back to some of the just a couple of slides from what we had talked about before in the first series, or the first installment of this series, was smart sensing in our everyday lives. We know that everything is really monitored at this point because of our attachment, especially to cell phones, right? So we know what they can capture, but we also know in all aspects of our lives, whether it be at work, certainly, uh, home, the appliances that we use that are very smart now and are connected to our networks in our own houses. Certainly with automobiles, self-driving cars, that is an immense amount of sensing that goes into automobiles now. And then even also in entertainment. So we know that sensing happens all around us, and we tend to think we know about all of that, but sometimes we know that, or we discover that things are happening without our knowledge. So we're going to concentrate on things that we know about today. So just to, again, some information from last time, what are some of those sensing devices that we see? And here's an eye chart full of different types of sensors that might be incorporated in many of these things that we would encounter every day in our lives. So bringing it forward to this term of Industry 4.0, just to recap, mechanization was Industry 1.0, 2.0 was electrification, 3.0 was the installment of computing in our environments, and then Industry 4.0, where we think we are now, because 5.0 is on the horizon. It is an effort of these, what we are calling cyber physical systems. So in the case today, we'll talk about Internet of Things. So these networks of devices that help us ultimately make decisions. So again, if we think about Industry 4.0, you might have your own perspective. But these are some of the big areas of Industry 4.0, and Internet of Things, as you see on this chart, is one of those. But we can't necessarily talk about one without the others. And certainly with cybersecurity, a term that we are very concerned about in the present day, and integration of everything. So we tend to think in the Internet of Things, things are easily integrated, and often they are, but it is sometimes a difficult task to get things to be integrated. So for our discussion today, we're going to still reside in sensing, but we're going to look at some higher levels in our automation hierarchy that lead us to decision making. So we're concerned about monitoring and control of devices, but ultimately we want to make decisions based on sensing in a process. And so for industrial sensing, we might think of cameras, we might think of photo eyes, then those things might be installed on a conveyor line, along with barcode readers. We might, within a process, look at things like temperature and humidity and power use, and things like weigh scale. So a lot of quality happens at the end of a line. So in packaging, so if we think of a large retailer that might be packaging to send direct to a consumer, they weigh packages, and there are things in that package that have a known weight, and as it's going down the conveyor line, it gets weighed, and if it's under a certain weight, it gets flagged. If it's over, it gets flagged. So pressure and weigh scales are also a common means of sensing in industrial environments. So last time we broke ground with what a protocol is and why it's needed, and it is a formal. It's a list of formal requirements and standards, including syntax, restrictions, procedures, error recovery, and synchronization. things that are very well defined in a standard, but perhaps not things that we really want to pay that much attention to. We want to take these things for granted, and that's fine. And so last time we looked at some of our typical industrial protocols that are available in control and in um, PLCs, for instance, programmable logic controllers. So these are some of the common industrial protocols, some of which have been around for many decades. And last time we looked at this particular protocol called IO Link, and IO Link is one of the newer protocols. If we look at a history, that allows devices not to just send a status, whether it has sensed a product going by it in the case of a photo eye, or a particular weight in the case of a weigh scale, but it also communicates all sorts of other information. And what I like to say the most about this other information is to think about it being the health of the sensor. So is a lens on a photo eye getting dirty? Is it approaching, is the sensor element or whatever is doing the sensing getting weak? Is that laser beam that it's sending out to do a displacement, is it not of the energy that it once was when it was brand new? So there are things that it can communicate that are very important when we think about maintenance. And so we want to be able to predict things when they're going to happen so we can intervene and fix things proactively. So two more, which you will pick out here on this graphic here, but on this particular slide, we see the two that we're going to address today, MQTT and OPC-UA. And you can think of over on the left-hand side with the MQTT image, down at the bottom, you can think of all of that. At the bottom are sensors, and then it gets pushed to maybe something what we call operational technology, could be a programmable logic controller, and that goes eventually somewhere, right? Whether it goes into an MES system, a historian, to collect data and store data, and then we do some analytics on it. So there's the level where we're doing the sensing. There's the level that we're doing some of the more higher level management interests, right? Likewise with OPC-UA, a little bit different take here is that we're looking at systems. But within those systems, there are devices, there are sensing devices within each of those pieces of equipment that are doing the same thing. So I want you to think about these two protocols on equal terms because they're used much the same way. So MQTT is short for message queuing telemetry transport, and it is an ISO standard. It's been around for a while, and it's used in many of our everyday lives. So when we think of the Internet of Things, it probably uses this MQTT protocol to communicate. And as we know, things are put on the cloud. So a lot of these devices are using MQTT protocols to talk to things in the cloud. Right. So we see these things on in smart energy, health, banking services, and many more. And it, like I mentioned, it was conceived for the Internet of Things. It really made its way into the industrial world by way of things that were more consumer oriented. So it does have its place in IIoT, the Industrial Internet of Things, as well. So that's why we're going to talk about it today. The positives is that, which there are quite a few, but notably that it uses something called a publish and subscribe model, and we're not going to get down into the weeds there with that, but it is a little bit different way of how typical industrial communication protocols work. Uh, it's very efficient. There's no specific addressing scheme, so it is very flexible. It is free flow, bidirectional. It doesn't require a tremendous amount of bandwidth. So when I'm putting packets up across my Ethernet, it is very low bandwidth. It doesn't require a lot of information to be moved. And it supports millions of connections. So when we talk about brokers here in a moment, we can put many devices on a network. And because of the low bandwidth, we can kind of push the boundaries on the number of sensors that we can handle using this protocol. Some of the drawbacks is that there are some questions as to interoperability with other standards, and whether this really will have some longevity in the future. I think it will, but as we will see, OPC UA, it's another protocol, does many of the same things. And some security isn't addressed for some of our infrastructures. So OPC UA, also known as Open Platform Communications Unified Architecture, is very similar to MQTT. It was developed in the early 90s, even probably in the late 80s, by the OPC Foundation. And it has been used in industrial environments and industry for many years since then. Unlike MQTT, it was really developed for industrial automation. And it is the UA is an extension of its origins in OPC, which is a data exchange standard. And this is something that I have used for many years in programmable logic control. And if anybody remembers something called OLE, object linking and embedding, it really falls into that category of moving data. And I used it many times to talk to databases. So it is an older standard. It is an industrial standard, but with the UA, it extends itself to be very much like MQTT. So the old OPC standard had some security issues, some data contextualization issues. So they developed the OPC UA extension, more secure integration with multiple data servers of different types. And it has this on-demand messaging architecture that is very much like MQTT. So back to a term or a set of terms that we may not have been exposed to in many years, but the server client architecture is how it works. It works under those conventions where there's something pushed to a server, there's a message that's pushed to a server, and then clients can request that message from the server. So when I mention the pub sub or the publish and subscribe, this is really what we're getting at in the server client architecture. We're sending information to a server to be stored, perhaps, And then for any client that is out there, any device, it could be a piece of software, it could be a device that is acting as a client. It wants to pull that information from a server. So the two protocols are agnostic in a sense, in that we don't really need to know the detailed knowledge of how the information is moved and what the device is and the protocols and the underlying system protocols that are used. We don't need to be exposed to them. So it makes it a little more friendly. It makes it a little more plug and play, if you will, like USB. So what's the goal? So we want to be able to get information in real time. We want to be able to store it, because we have this ambition that data stored is data that will benefit us from an analytics point of view, and hopefully we want to make decisions in near real time based on that data. So decision making takes efforts from every point in our automation hierarchy. And if you're not familiar with our hierarchy, it is a 5-level pyramid that I learned many years ago, starting from what we call the field level or the device level, which is our sensor level. And then we go into control, and then supervisory, and then ultimately we get to the highest point of that pyramid, the apex, where we're talking about MES systems, management level systems that we rely on to make decisions for our businesses. All right, so that's where that decision making happens. And so the historic problem has been about integration and communication. So how we go from one level to the next in the pyramid and share that information. So in the end, what we want to get out of this are things like metrics, right? So we want to know what our equipment efficiency is. We want to know what our downtime is. We want to know where things are. So when we think today about mobile robots, right? So we talk about fleet management. We want to know where that fleet is. Are they all swarming in a corner? If they're all swarming in a corner, we probably have a problem, right? So things like that. Predictive maintenance, remote monitoring. I want to be able to do things from my office, not be on the plant floor. I want to be able to do things from my home. I want to be able to really leverage the remote nature of our modern day systems. Scheduling, SPC, process control, that sort of thing as well. So in our information model that we're going to look at today, and this is kind of a tweak on the things I'm exposing today, are some things that I want you to identify here are the devices, which are those blue ovals. I want you to think about where that information goes, and more that orange circle where it might be an SQL database, for instance. I want you to also think about maybe that database is on a PC in front of me, maybe it's on the edge down on my production floor, or maybe it's even in the cloud. So if we look at the green circle, those are cloud services, right? So that's my Azure, and that's my Amazon Web Services, AWS, Google Cloud, so forth and so on. The thing in the middle, that yellow oval, is the basis for this publish and subscribe model that surround these protocols. So we have what we call a broker involved. So, and that broker term is an extension of how we would think of stock market brokers to be, right? So it is taking information from our devices and it's pushing it to the cloud, it's pushing it to a database, it's pushing it to a spreadsheet, so forth. That's the glue in this whole system that we're going to talk about today. So what if I don't have smart devices? I don't want to think that you know, we have to go out and upfit our entire old environment with new devices. That's not feasible. So here's a similar network with older types of devices. And the key here is looking at what's termed a gateway. So we can accomplish that information model that we just saw via a device that we call a gateway. So that gateway, again, a physical device, you go buy it, and it serves the purpose of translating information coming from maybe some old sensors, some discrete sensors that I have that can't, you know, talk to me about their health. So there's a limited amount of information that can come from them, but it's still important to be able to use them and capture that information. So we introduced this idea of a gateway that allows this message to still happen. It is able to convert that message from a relatively dumb device and push it to my information model. So the proof is in the pudding here, right? So I wanted to show you an application here towards the end. And this is something that is very real, because what I'm about to show you is something that is actually in use right now. So it is I want to pose a scenario. There's a small manufacturer making continuous improvements. It could be why you're here today, right? So you want to make improvements to your process. And this particular manufacturer would like to update some old processing equipment in a production cell. And there's an opportunity for that manufacturer to leverage a grant. And this particular grant comes from our Department of Energy. They'll help us, or the Department of Energy will help us through this grant replace some equipment, some technologies that will help make us more competitive as a manufacturer. The kicker here is that we've got to be able to show that there's going to be some energy savings that is going to happen. So we're going to kind of go to the extreme here. So I wanted and I love this graphic because hopefully you don't have machines like this, but it drives home a point, because maybe if you look at this and you can pick out, well, there's a control cabinet in the background, and just by the size of that being equal to the size of the machine itself, it might be a good indicator that it's an energy hog. It applies very well here, because we know, just by it perhaps being a black and white figure here, that there's not a lot of intelligent sensing going on this device or on this piece of equipment. So there's no way with this piece of old equipment that we might even know what the power requirements are. By, you know, we can look at a nameplate, we can figure that out, but perhaps that's not a good measure of what it consumes for power. So we need to be able to monitor and do some data capturing of that energy that's being used for this old piece of equipment, to be able to show for the grant that there'll be some energy savings that will happen. So I want to be able to find a commercial off-the-shelf COTS device that I can set up or help this manufacturer spec out and set up, that they can develop a use case for that grant. So what we might have been dealing with in maybe some more modern equipment is a programmable logic control. So a lot of conveyance systems, for instance, are the smart conveyors are really driven by things like PLCs, programmable logic controllers, and a lot of processing equipment is controlled that way too. So in our traditional system, we might have a PLC that is in there in that old piece of equipment. Probably not a PLC, but nonetheless, most of our equipment that was bought in the past 30 years probably has some element of a logic controller in it. So in our typical system, we might have that sitting inside of our piece of equipment. We might have the opportunity to have an energy meter that is on that piece of equipment, or I can purchase one and plug it into my PLC and talk to it that way. Using a protocol, again, another protocol that you'll identify here is Modbus, right? So I have these devices that are talking to a PLC, and the PLC is looking, or it's pointing to a cloud. So that PLC, I can upgrade an old one, I can go buy a new one, and I can have it talk MQTT, I can have it talk OPC and I can do the same thing. But what I'd like to do is not have to invest in a PLC or invest in metering that talks another proprietary or another standard Modbus, that I have to have a PLC to be able to effectively get that messaging across. So I'm going to try to get rid of that need for the PLC. I'm going to try to get rid of this need for Modbus. And I'm going to look at a device that is going to be low cost, and it directly talks MQTT, it directly talks OPC. So I just replaced perhaps a several $1,000 PLC, perhaps a several $100 to even more than that, devices that talk another standard, with a single device like this that is very low cost and able to talk to that cloud platform via these two standards. So a smart sensor. I need a broker. So I mentioned that before. I need some sort of middleware to handle messaging. And then the clients. And I want you to think of a client as being a device, but I also want you to think of a client as being a piece of software, right? So I need a client to push information somewhere, and I need a client to be able to pull information another. And that could be the software. And I want you to make sure that you have some patience, because it's not an easy road. So the sensor, as you saw before, this is a low-cost sensor. It is made for an industrial environment. It is packaged, it is sealed, it has an IP rating on it. This one happens to be an energy monitor. So I can put it onto a leg or a line of my device and determine how many amps are being drawn by that device or that piece of equipment. The broker itself, that middleware, the part of that information model that is handling my messaging. In this case, there are a number of free ones. So I love the word free. Hopefully you do too, because it makes these preliminary cases easy to prove if you can do things for free. In the case that I'm going to show you today, I used one called Bbot, which is a open source free broker. I need a conductor. I need a client that can massage some of that messaging as well. In this case, there are also a number of free versions of clients out there. I'm going to use something called Node-RED, an open source free client. And then we need something for data logging, analysis, and visualization. And we probably all know Excel and the power of Excel and may already use it in our everyday lives. There's Power BI and for doing some cool things with dashboards and kind of elevating what we can do for charting out of Excel. But there's also Node-RED, which I just mentioned as being a client. It can also do some dashboarding for me too. So just to revisit how this information flows is I go from my sensor, I go to a broker, and then my broker is servicing clients. So I'm publishing to a broker and I'm subscribing to a broker. In this case, my device that I showed you earlier streams out information. And the stream of information is exactly what you see right here. It has device-specific information. So remember what I said, a photo eye, a relatively dumb device, is basically going to have what we would call a contact closure, right? So it's either open or closed. There's either something in front of it or not. That's great for a photo eye. But a device like this, I might want to extract other information from it. In this case, there's a lot of network information that we see streaming from this. But there's the data, the important data that comes from this particular device is the current, right? Is that measure that I want to capture or translate into energy usage. So looking at Node-RED, the client itself is a piece of software. In this case, like I mentioned before, this is free and it is graphical. So I wanted to illustrate something that was low to no code in being able to move my messages around, my information around. And this is a pretty cool example of how to do that without really any coding. So I have there's 3 blocks here on this graphic. And that first block that looks kind of more lilac in color, that is my MQTT message coming in, right? So I'm talking to a broker, and that broker is off in the cloud. And this particular block in this diagram is pulling information from that broker. We see that there's this modify payload, the more or less orange block there. I don't care about all of that other information that the sensor was really supplying. I care about how many amps are coming from that sensor. So I'm going to strip the excess away from that by this modify payload. And then I'm going to put it somewhere. I'm going to put that information somewhere. In this case, it's just a block that I'm calling device data. And I'm going to show you in a second what it's spitting out. So the payload, I had to, there's 2 lines that are important here that basically are looking at that message that's in my broker, that's being handled by my broker. And I'm identifying that it I'm interested in the RMS current underscore MA, milliamps in this case. And then I'm just going to republish that in a sense to this device data block. So if we look at a screen within the software, we can actually see how this information is getting pushed, and I can time this. I can tell the client, in this case, the sensor, on the upstream side of this, to just send information every so often, and that's how we see it on this on the right hand side. Is that I'm going to start seeing information come in every so many seconds. In this case, I think I had it come in every 10 or 20 seconds or something. So it is only giving me that information. That's that more or less blue or indigo data object right there. That's the information that I'm trying to gather. So in data logging, I ultimately want to put this somewhere. Again, I can use the same software. I can connect to the same nodes that I had before, the same blocks that I had, and refine it again for making it suitable to push to a CSV format, and then from that CSV format to a file. In this case, I'd like it to go to a file that I can read via Excel. So then that's what we see here, right? So the data logging nature is taken care of at this client. So I can open this up in Excel, or I can also do my analysis in Excel, or I can use this client to do that too. So I can choose another element from this same client and chart this. Doesn't have to be in Excel. I can do it also in this client, in this free client software, right? So I can actually start building a dashboard, something that's meaningful. In this case, we can see that information being displayed where it kind of looks like a more or less a chopped off sine wave, but it's indicating when my machine is on and doing some processing via when it's not, via when it's idle. So maybe it's doing these routines where it's working on a part and then turning off. But the important thing is that I'm capturing this information. I'm doing I can do a quick calculation on how much power it is using at any given moment of time. So in running short on time, so I wanted to wrap this up. So what we're doing here is we're doing some really simple sensing, but obviously pretty important, right? So it is upfitting something that is old, may not have the ability to communicate some things to a cloud or to a spreadsheet, which is really might be of ultimate convenience for me. And I'm going to use an off-the-shelf device, inexpensive. I'm going to use this free cloud broker. I'm going to use this free open source instance of software to take that information that I need. And, you know, I'm granted, you know, you're buying a package like Excel, but it might be something that you already use, already have. You can push this to, you know, Power BI, you can push this to Tableau, you can push this to different places. That might be a cost, but you might already have those abilities. And I'm doing this with all very little coding. So really what I like to illustrate, granted, I think more or less most of us are kind of in this industry 3.0 to industry 4.0 transition. But we might even think of this as an industry 2.0 to 4.0 jump, especially if we go back to that graphic where that black and white photo where we had such an old piece of equipment. So lessons learned here are that, or what I'm trying to convey is, don't let protocols bog you down. There are a tremendous amount, and every time I go look at this every so many months or years, there's another protocol that has maybe a different extension, like OPC became OPC UA. There's a modification to some old specifications that happen. And that's just the way that it is in the standards world. Don't let that confuse you or make unnecessary frustration for you. Industrial sensors, I brought this up last time, are becoming commodity items. What a device cost me 20 years ago might end up being lower cost now, but it might end up being about the same cost. But I'm getting more information out of it. Okay. And because of supply and demand, we're seeing a lot of this, and manufacturing methods. These are more or less commodity items now. Our cloud reliance is increasing. People are becoming more comfortable in sending things to the cloud. That is a good indicator that we are progressing as a society, I think. That we are putting trust in data storage and data lakes that don't necessarily reside in our four walls or on our PC. And that is because of security and cybersecurity. And these protocols support that. These newer protocols support high levels of security. So when with a small test case like this, and I want you to think all of this is scalable. If I can do it for one device, in this case, an energy monitor, I should be able to do this with similar simple devices in a similar fashion at a similar cost. So start small, it's scalable, it's doable. And this is what I wanted to help you with and help you understand. That's part of why we're here at IES. So with that, I want to turn this back over to Susan to talk about MFGCon, because I want you to come visit me at MFGCon, where I'm going to have this demo and a similar one to show you that we don't have necessarily time for today, but I want to be able to pick some of these things apart in real time. If you come by MFGCon, I'll show you what I did to produce this presentation. So I'm going to turn this back over to Susan. And Susan, if you want me to step through the remainder of the slides, I can do that for you.
Okay, thank you, Jason. I'm going to go ahead and stop our recording. So that ends our presentation.